This is question number one, folks, taken from an AS Pure Mathematics paper. I think it's called, TAD Maths, I think it is, or T Maths. Okay, looking at, just think some exam style questions. Looking in this video, specifically at coordinate geometry, so equations of straight lines and intersections, okay? So here's the question. The straight line L1 passes through the points A, which is 320, and B, which is 13, 0, okay? The straight line L2 has gradient 1/3 and passes through the point, sorry, I better speak to this, sorry about that, point C, okay, 0, 5. The point D is the intersection of L1 and L2. Show that the length of AD is K root 5, where K is an integer. Okay, so step one, let's work out your L1 and L2, okay, in y equals mx plus c. So L2, hopefully you can see, okay, from just C maths here, hopefully, y equals mx plus c. So y equals a third x plus c, or x thirds plus c, or 1 over 3x plus x plus c. Obviously, c is what we call the y-intercept, so this will be our plus c. Okay, and our m, which our gradient function, is equal to 1/3. Okay, so that's L2. What about L1? Okay, slightly more trickier. I've got 2 points. Step one, work out the gradient, okay, of the 2 points. So we do difference in y over difference in x. So we do 0 minus 20, which is minus 20 or negative 20, over 13 minus 3, which is 10. So we get minus 20 tenths, which simplifies to minus 2 or negative 2. So L1 so far has the equation y equals minus 2x plus c. Now to work out the plus c from L1, we're going to substitute in either coordinate A or B. Okay, I'm going to go for B here just to make it a bit easier for numbers. So we've got 0 is equal to minus 2 lots of 13 here, so that'll be minus 26. Okay, plus c. I'm now going to add 26 here to both sides, okay, to work out what c is. So c is equal to 26. So L1 has the equation y equals minus 2x plus 26. Okay, so that's job one. Now here's the next part. Okay, so they intersect, okay, at point D. So that's when we obviously equate both equations. So we're going to have minus 2x plus 26 is equal to 1/3 x plus 5, okay? Now to make it easier and avoid like fraction work, I'm going to multiply everything by 3 to get rid of this third here. So I'm going to have minus 6x, okay, 26 times 3, okay, let's work it out. That'll be 80, so that'll be 78 if I'm not mistaken. Is equal to x plus 5, okay, remember, third times 3 just goes to 1, and then 5 times 3 makes 15, okay, and then it's a 5 there, okay, so that's the first part done, okay. Now, next step, okay, I'm going to add 6x to both sides, okay, and then I'm going to subtract 15 here at the same time, so we're going to have 78 minus 15 is equal to x plus 6x, so that'll be 7x. Okay, 78 minus 15, guys, here, you get 63. So you have 7x is equal to 63. Dividing by 7 here on both sides of my equation to get what x is. So x equals 63 sevenths. So x is equal to 9, guys. Now that I know what x is, I can plug it into work out what y is. Okay, let's plug it in here to L2 here, slightly more trickier, but let's give it a go. We have 1/3 of 9, so 1/3 times 9 makes 3, plus 5 makes 8. So the coordinates of D is 9, 8. Now we're asked to work out the length of AD, so we're going to work out the difference in x, different in y, and then use Pythagoras' theorem. Okay, so that's point D now. So from 3 to 9, we have 6, so yes, square root of 6 squared plus, and then from 20 to 8, we go down by 12, but again, Same as doing your 12 squared, okay, or minus 12 squared, okay. So that'll be what? That'll be 36 plus 144, okay. Sorry guys, yeah, I'm doing this in my head a bit today. I apologise if I'm going a bit fast. So 144 plus 36, that'll be the square root of 180. The square root of 180, which if I simplify that, okay, simplifying thirds, that's going to be root 36 times root 5. Root 36 is just equal to 6, okay, because that's the biggest square number factor that goes into 180. Okay, so we get 6 root 5. So k is equal to 6. And that was quite a beast of an 8-mark question looking at coordinate geometry for A-level pure maths or AS pure mathematics. Okay, going over, yeah, equations of straight lines from just C maths. Okay, yeah, knowing, yeah, parallel lines, yeah, okay, intersection. So intersection is when you equate, yeah, both equations together, okay, because that's where it crosses on, yeah, on the X and Y axis. Solve the equations, yeah, from GCSE level maths. Rearrange it, yeah, work out your coordinates, and then use Pythagoras to work out distance, yeah, so the modulus or distance of A to D, okay, is equal to the square root of x minus x1 all squared plus y minus y1 all squared. So work out the difference in the x coordinates, square it. Work out the difference in the y coordinates, square it. Okay, now technically here, it's meant to should be like a minus here, but again, if you square a negative, you get a positive. Okay, so that's why I didn't put a minus there. But yeah, it's the square root of 6 squared plus in brackets minus 12 all squared. Okay, which gives you the exact same answer. Yeah, essentially you're working out the modulus of that, okay? So the modulus here of minus 12 is equal to 12, okay? Because yeah, it's a length, yeah, it doesn't really matter here whether we've got a negative here, because obviously if you square a negative, then we get a positive as our answer, okay? So that was a beastly, quite a big 8-mark question, which I think would appear on the end of your year 12 exams, okay, for AS pure maths, and also it's good revision for A2 pure maths students here, or anyone in year 13 that is recapping A-level pure maths, okay? Thanks for watching, take care, all the best.